This is question 5. All right, I am going to start by underlining some of the key terms. The number of molecules. We haven't seen this in a while. For some reasons, people sometimes think that the number of molecules means the number of mole of molecules. Let me assure you, it does not. If the question wants for the number of molecules, it's not the number of mole. If it wants for the number of mole, it has to say the number of mole. So this is not one of the cases when one thing means another thing. So number of molecules is not the number of mole, is actually how many molecules do you have. And if you remember, it is, well, one way to represent it is the capital N, and there is a relationship between the number of molecules or particles in general and the number of mole of that substance. And the link is Avogadro's constant. So this is the formula for that. If I multiply number of mole with Avogadro's constant, I will get the number of molecules. Okay, Avogadro's constant, you can find, you can look it up using the data book. It's given to you, which is 6.02 times 10 to the 23. I don't remember the actual number. I think there is an actual number now. It's 02 something. I looked it up last year and then I forgot now. So I'll look it up again. Anyway, the number of molecules present in 224 liters, so we're given volume in liter, of methane. Methane is CH4 and it is a gas. You need to know that it is a gas. It's definitely a gas at 0 Celsius degree. I think it liquefies at negative 100 and something. I may actually get it wrong. It's definitely a gas at 0 though. And because it is a gas, you are allowed to use the universal gas law. So I think one of the issue with these questions I can see already is people probably do not recognize methane as a gas, and that is going to really hinder your progress because you wouldn't know where to begin. So you need to know methane is a gas. Common knowledge, I think. Most people know what methane is. Well, if it's not common knowledge, you should make it common knowledge. This is a universal gas law. You are allowed to assume universal gas behavior in high school. Pressure is in kilopascal. Volume is in liter. And temperature has to be in Kelvin in order for you to use the universal gas law. So they give you temperature here. I started highlighting, but it's not in Kelvin yet, so that's something we're going to have to do. And they also give you the pressure. So that's all the important or key terms, I think. I'm going to summarize information again. So you're given volume in liter, you're given methane, which is a gas, you're given temperature of methane, which is 0 Celsius degree, and you are given the pressure, which is 101.3 kilopascal. And the question is, what is the number of molecules, so capital N, of methane? Okay. Now we need to find or establish a relationship between what is already given to us and the unknown here. Now I know that the unknown, I think one of the ways to find the correct relationship is just to start with the unknown and how many ways you know to get to the unknown and what you may be able to get from what is already given. There's only really one way to get the number of molecules, and that is using Avogadro's number and the number of mole. So I know ultimately I am going to need to multiply the number of mole of methane together with Avogadro's constant to get the number of molecules of methane. Which means that I need to find, I think I'm just going to write it again here, I need to find the number of mole of methane. And you already given volume, temperature, and pressure, and you have this relationship between those three quantities, and number of mole is also part of this formula. So I know that I can find number of mole of methane. And I think it's very important to remember that you're only allowed to use this formula because methane is actually a gas at 0 Celsius degree. Please don't go and just use it for anything and everything because solutions definitely do not follow this formula. Okay, so we can go PV over RT. And once again, because this formula only works if all the quantities are in the appropriate units, I have to convert, this is already in liter, but I need to convert this to Kelvin, which is 273. Okay, so number of mole, step 1 is going to be finding the number of mole of methane, and then step 2 is to multiply that with Avogadro's constant to get the number of molecules. And then we get to execution, so 101.3 times 224. Oh, the gas constant is 8.31. So 8.31 times 273. Okay, something is 224. It's very exciting typing things. So 9 point. Oh yeah, I think it'll be okay. 97 mole. You can definitely use exact value, and I am going to multiply this with Avogadro's. So 9.97-ish times 6.02 times 10 to 23. Are we looking at B? So we have 5.999. So maybe 6.0 times 10 to the 24 molecules. So yes, it's B. That's the answer. That's definitely more than a mole of methane. That's it.